Hey everyone, I'm about to show you a really cool way to optimize your simulations. Simulating frames that we don't need is an absolute waste of time. So this is something incredibly important, but Houdini doesn't necessarily make it very easy. Sure, we can set a start frame for our simulation, but do we always know what that start frame should be? Sometimes it does change, and so we can forget and actually miss certain values that we should have had. And then one of the biggest problems is actually at the end of the simulation when the sim has run its course, especially if you've got very quick little bursts. You might have no values, but still more frames, and now you keep calculating and cooking all of those frames that you don't need. Now, sure, there's no density values, like in a smoke sim, for example, but you still have to calculate everything that you're referring to. So every SOP that you refer to has to cook, and inside the DOP as well, it has to calculate the solver. And there are certain things going on inside of the solver that are still calculating every frame, even if there are zero density values, because the sim, the solver itself, does not know that density is all that really matters. And so as soon as there's no density, it just skips ahead. It has to keep calculating everything. Sometimes it's not even only density that matters, it's temperature and other values. So it can't make any assumptions like that, which is why it has to cook everything. And that is too heavy, right? So I'm going to show you a way to automatically calculate your start frame and to actually calculate an end frame and not simulate or even cook those frames, so that we're able to basically set an end, right? You'll notice that a normal DOP does not have an end frame. It only has a start frame value, and it doesn't let you set an end. But this method kind of does let you set an end, and in fact, it's a procedural end frame. So yeah, it's really, really useful, and I love the fact that it is automatic. And one of the reasons why it needs to be automatic is because things can change. Now, if you're setting, let's say, an explosion, you might be calculating or like keyframing when that source is released. So you know exactly what frame it's going to need to simulate from. But what if the source we are using is based on animation? So I'm going to show you my setup here where I've done exactly that. I've taken some animation, so we've got our test geometry crag swinging his hammer. I've time shifted it forward so that in the beginning he basically just picks up the hammer and does the big swing. And then I'm isolating the hammer, converting it so we have geometry to use, calculating velocity, and then time shifting to a frozen frame where I can scatter, calculating my source prim and source prim UV so that I'm then able to attribute interpolate. While it's frozen, I'm calculating the rest frame, the rest attribute. And then my attribute interpolate is using that source prim and source prim UV, so now I get moving points that are not receding. And we have a rest attribute. And I'm using that rest to set a density, so it's a little bit noisy. And then here is the real trick. I'm multiplying by a fitted speed. So I'm taking the speed of my velocity, right? So the length of the velocity, fitting it between a minimum and a maximum value, and then fitting that to 0 to 1. So below 2, a speed of 2, it will have no density, and then between 2 and 5, it'll fade up to a multiplier of 1. What that results in is that when it's static, there's no density, and then when it moves, there's density. Great. Okay, then I rasterize, and now I'm ready to do my pyro sim. Now, usually, you would have to now try and figure out where there is a start frame. So we might look at our source, scrub forward and figure out, okay, I see some density there. And if you really want to be precise, not even just trusting your eyes, because sometimes the viewport does not display well, you might want to actually middle click and check the number of voxels and say, okay, well on frame 66, I still have some voxel values. Let me go back a frame. Okay, now I have 0 values, 0 voxels. So 66 is it. Let's start from frame 66. Now we go and set our start frame and we go on. But if that animation is coming from the animation department, it might change. The speed might change, the actual movement of the character might change entirely. So now we have to go and remember, every time animation updates, we have to go and check the frame and go and set the sim to start on that different frame. And I guarantee you will forget. I've done it 100 times, right? And worse than it being shifted slightly later, where you just have a few wasted frames, the worse than that is when it shifts earlier, and now there's a few frames that you're not even simulating where you should have had density values, and it just doesn't look right. So really not a good idea to set that manually. So the other alternative is, well, why don't I just simulate all the frames? Because of course, if there's no density sourced, there's going to be no density cached. So the frames are not heavy. You know, there'll be like 1 kilobyte or 3 or 5 kilobytes. Not a problem. But the problem is, it still has to calculate those frames, especially if you have, in this case, I've got a moving collision object. So I just used my toy, the rubber toy, turned into a collision volume, and it's moving, right? And I've given this probably more voxels than it needs, but just to help illustrate the point, right? You can make this really heavy, and even on frames where it's not calculating any density to simulate, it has to load the collision volume, which can be really heavy. So obviously now, if we go from the very first frame, you'll see that when I hit simulate, we're simming at about 2 frames a second instead of real time for all of these frames. And I mean, this could be a lot of wasted frames. It's especially annoying when you're trying to iterate and work with it, because of course you have to keep going back to the first frame. And then, like I say, there's a whole lot of problems with if you then do set it to be frame 66, because that might change. Okay, so that's a problem. Also, once the simulation is finished and the smoke evaporates, we've still got all these frames till the end of the timeline where, it's having to cook every frame, but the sim is done. Why can it not just stop there? But setting an end frame with a switch manually, again, is really dangerous, because anything that changes inside of the sim could cause it to last longer, and now it suddenly pops out of existence because we didn't let it fade properly. Okay, so now that we know the full extent of the problem, I'm going to show you the solution. Right. So I've got a subnet here. I'm taking my density, and what we're basically going to do is figure out whether or not there are density values above a certain threshold. All we want at the end of this is a condition attribute that lives at detail level. It's 0 when it is not true, right? So it's false, and then it becomes true on a certain frame. That basically shows when our density comes into existence above a certain threshold. Right. Now inside, all I'm doing is isolating the density field. You could isolate a different field if you want to, so you could test temperature, or you could even test something like velocity if you want to do, rather than testing the density, you might want to test the length of the velocity. That's another good way to go. In a volume wrangle, we're testing that threshold. So I'm setting a threshold. I'm basically saying below that threshold, I'm just going to multiply my density value down to 0. And those voxels, although they are now multiplied down to 0, they still exist, right? So what we want to do is deactivate them. So we use a VDB active, and then we set to deactivate. And this threshold can be 0 because we are multiplying those values down to 0. All we're doing is essentially switching off all those values, which, if we have some voxel values, let me move forward to where we have some values, and I set my threshold high enough, it's going to delete all of those values. And because the voxels actually get switched off, you'll see I now have 0 voxels, as opposed to here I still have 38,000 voxels, the same as I did before the threshold. It's just that the values changed, right? So we have to deactivate in order for this to work. Now I'm going to set my threshold back down to really, really low, because I'm just trying to get rid of the very low values that might not really give me much density to work with, and instead saying, above this threshold, are there any voxels at all? So now that we've deactivated, we know that there's a certain number of voxels that are above that threshold. We need to count them, and that's where we're going to get our condition. So we use another wrangle, but this is an attribute wrangle now, because I'm not working on volume level. I'm actually working on detail. And the real trick here is that we don't put anything into the first input, because I don't actually want to keep this geometry, right? It's heavy to keep it and calculate it, and I don't need it. All I need is a value, 0 or 1. So we can make it with nothing in the first input, but then we have to set this to be on detail value, right? Detail level. If we run over points or primitives or vertices, then we have to have points and primitives and vertices, okay? And we do not have that. But with detail, it'll run once no matter if there's nothing on the first input. So now what we do is we check the active voxel count, right? Using a prim intrinsic node that basically is doing exactly what I'm doing here, middle clicking and looking at this number of voxels. That's all this expression is doing. And then we're saying, are the number of voxels above a certain threshold? In this case, my threshold can be 0 because I don't really want to set a value that's higher. I just want to say, are there any, even one voxel that is above my threshold that I have set for the density? And if the answer is true, then that's when I want to set my start frame. Okay, so my count threshold is 0, but I've exposed that as a parameter so that we can change it if you want to. The threshold that really matters is this, where we're choosing a density threshold and saying everything below this threshold doesn't count, but anything above, now we say how many are there. If there's at least one voxel, I'm going to count that as the start frame. Okay, so that just sets our condition, which is a detail attribute. Now, this value, if we scrub through, you can see it goes from 0 over here, and then it does become 1, although it seems to stutter a little bit. There's a frame, 61, where it becomes true, then it goes back to being false for a few frames, and then it becomes true again on frame 66. So there is obviously a value here on frame 61 that is enough to trigger it. Okay, and then it also, after a while, goes back down to 0, and then goes back up to 1, I think, later down the line, right, depending on any movement we have. So this is good for some things, but in terms of trying to calculate a start frame, what we need to do is basically figure out when the switch happens the first time, and we don't really care about the rest. So the way to do that is using a solver, okay? Now, it's really important, the step that we did where we made sure we're not keeping all this heavy geometry, just an empty geometry with one attribute, is so important, because with the solver, it now becomes much lighter to calculate every frame, because what's coming into the solver is not heavy geometry, but just this empty geometry with one value. Okay, so we go inside the solver, then we're checking our previous frame in the switch, which I'll talk about just now, and we're taking our first input and we're setting a start frame value. Now this start frame value is just set to a default of -1, but if that condition is true, then the start frame value instead is overwritten with f at frame, which is our current frame number, right? Now, if it's allowed to, it will keep then overriding that value. So it'll go from -1, and then as soon as the condition becomes true, it's going to just keep overriding it with the current frame number, which will keep obviously changing every frame. But the switch is going to help us no longer assess that first input, and instead only look at and consider the previous frame input as soon as that condition hits true, okay? And the way it's doing that is it's checking the condition value, so that detail level attribute, we're doing an attribute value test at detail level, looking at an attribute called condition, and we're saying when it is not equal to 1, right? So basically when that value is 0, it's going to keep looking at the second input, okay? So this will be true, therefore it will consider the second input every frame, okay? As soon as condition is 1, then this will be false, therefore it takes this first input only. And then we're stuck in a loop where it's looking at the first frame, the condition is true, so it comes back in, and then it looks at it again, and it's still true, so then it goes back in again, and then we're stuck in this infinite loop, and that's what we want, all right? So, and the reason why that would have a condition equal to true is that on the first frame where this comes in and the condition is equal to true, this will still be false because it's looking at the first input, the previous frame. So this will be 0, but here it's 1. It goes through the switch, and then whatever comes out of this out comes in on the previous frame input on the next frame, and therefore we're now in the loop of condition equals 1, condition equals 1, condition equals 1, and so on, and now it just stays stuck on the previous frame input. Okay, so what that results in is, if we look at our details over here in our geometry spreadsheet, it's 0 and -1 for the start frame, until all of a sudden condition becomes 1 and start frame becomes 61. And then nothing changes, because you see the start frame, although it wants to be overwritten, is only overwritten whenever we assess the second input, and as long as condition is true, the switch will look at the first input, which is the previous frame, and it no longer overrides the start frame. So this now, instead of going back and forward, just goes from a 0 value right in the beginning to a 1 and gives us a start frame. Okay, now you'll notice something. Even when I scrub backwards, it doesn't switch back to 0. That's because I've turned cache simulation off. This is a vital step. Caching it makes it very difficult to work with. It doesn't really recalculate itself the way you would need it to. Turn cache simulation off so that it will recook when you run your simulation, especially with your file cache. If you have under advanced, if you have initialize simulation ops on, then it will much more easily recalculate this. A lot of the time it gets stuck if the cache simulation is on. Okay. And then the final step here, because what we really want out of this is not even this value that goes from 0 and then eventually becomes 1. We don't really need that changing value. What we want is just this result, the start frame number. So we can just do a time shift to the end frame. So now it is non-time dependent. It's not recalculating every frame. It just does the full calculation in one go and spits out a start frame value. I've now got a null that I can easily refer to. And in my Pyro solver, I create a spare input. So you go under this little cog and you say add spare input, and which adds a spare input at the bottom over here. Just if you can't see it, you just may have to scroll down in your parameter sheet because it adds it right at the end. This will be empty, but you can refer to the sim start frame null or whatever you called it. And you'll see this dotted line if you have, well, actually, I think it shows it all the time, even if you don't have show dependencies. So you'll see the dotted line going into the side. That means this is working. Now, all we do is on our start frame, we refer to it using a detail attribute. Now, I'm using a Pyro solver at SOP level over here. You could also do this on a DOP. It's the exact same steps. With a detail attribute, we refer to -1, which is your spare input, right? So you don't use now 0, 1, 2. That's your input. So this is 0, this is 1, and so on. Instead, spare inputs are referred to as -1, -2, -3, and so on, depending on the number of your spare input. And then the name of the attribute that we're referring to, which is start frame, and then the index, which, since ours is just one value, the index is 0. Okay, if it was a vector, then it would be 0, 1, or 2, which is your X, Y, and Z. Okay. So now we refer to that, and it sets our start frame to be 61, which is great, because that's exactly when it should start, because that's when we found that there are some density values. In fact, I was explaining just now, and by looking at it manually, I figured out that it should be frame 66, which was a mistake, because I didn't realize that actually prior to that, there's a frame 61 where it actually has some values. Okay, so it just proves the point that you can easily make mistakes, but doing it this way, there's no mistakes. It just automatically calculates the very first frame where there are any density values above a certain threshold. Because of the time shift, it calculates that all in one go. And because of this switch over here, in a smart way that it looks at only the first input, which is the previous frame, and there's no heavy geometry like the volume still existing, what it means is that as soon as it hits that frame, so it'll be a little bit slow to calculate in the beginning if you have a very heavy source, but as soon as it hits that frame where the condition becomes true, it literally is in an infinite loop of an empty geometry with only 2 attributes on it. So it calculates the rest of the timeline in like almost instantaneously. So yes, there's a little bit of a pre-cook, but then it's really quick after that point, and it only has to calculate it once, and then it sets the start frame, right? So even when you reset this sim, it doesn't have to reset this, okay? So fantastic, we now have an automatic start frame. So I can have it start, and we haven't wasted those beginning frames, even if I wanted to set a heavy collision object. I still have obviously saved myself time, because these first few frames, there's nothing to calculate. Then we start simulating. And if the animation changed, it would change automatically, which I'm going to show you just now, an example of us changing the animation. But there's still one more step we need to do, because this is great for the beginning, but what about the end? And I'll actually show you my cache here, just so that you can see. I have this sim, and in fact I included my flippy as a collision object. And it swings around, and you'll see I've got quite a lot of dissipation. So at a certain frame, there's no more smoke left. But now I'm wasting all these frames, and what do I do with them, right? How do I know when to stop simulating? But if I had that heavy collision object for the whole timeline, well, that is a long time to calculate all those frames for no reason. So we're going to do something very similar. In fact, the condition subnet is based almost exactly on the exact same setup as here. You'll see it's the exact same nodes. The only change here is that I set when the count is equal to 0. Or I suppose you could have even said less than or equal to the threshold. In this case, my threshold is 0, so obviously the count will never be less than 0. But let's say you wanted to set a value of 10. Now it would be 10 or less is true, rather than 0, like more than 0. So previously we had greater than, well now we're saying less than equals 0. Okay. In other words, when there are voxel values, when there were no voxel values above that threshold, okay? So after culling to that threshold and deactivating those voxels, how many are left? When it's less than or equal to 0, then this condition becomes true, all right? Which is exactly what we want. We're basically looking at the sim and saying, when are the voxels all gone? And then the value becomes true. Now, what do we do with that true value? Well, again, we need to make this persistent using our solver, because we want to basically simulate the whole time while that value is false. And then as soon as it becomes true, we want to stop simulating. But it's a little bit different to the start frame, because we can't just time shift, figure out what frame it becomes true, and then set a parameter, because there is no end frame parameter for our simulations. Okay, there is no end. And once we've kicked off the sim, so once we've kicked off the cache here, the smoke sim cache, it cannot tell it to stop on a certain frame. Okay, there's a very advanced way you can do it, by using pre-frame scripts that you could on every frame figure out, and then I think you can kind of like trigger the end of the caching process, but that's getting far more complicated than we need to for this simple step, right? So how do we use that value to tell it to stop simulating? Well, the trick is we don't actually tell it to stop the sim. All we do is we switch to nothing, right? Switch to an empty input. Because of course, to cache nothing, even for thousands of frames, would be really light, really quick. And in fact, there's an added benefit, which is that if the animation had changed and there previously were values in those frames, let's say from about frame 200 onwards, so 200 to 240 here, we had values, we had some density. And then we've changed the values, and now those are empty. Okay, those frames have nothing. If we could just stop simulating at frame 200, well, we've still got on disk, we've got frames 201 to 240 that have values, which can become very confusing if we had to just load in that cache and forget that we had an end frame set. Now we're scrubbing through and our sim changes on that frame. it can get really messy, especially if you're doing that multiple times. So what we want to do is actually override those values, those frames that previously existed. We want to override them with a 1 kilobyte, basically just nothing file, okay? Which is a nice way to also keep your disk space, you know, basically clean up and override the previous cache with a new cache that even gets rid of frames that used to exist and now that no longer do, okay? So the trick here is to do this switch so that we switch to a nothing. But the really, really important part here is to understand that if the switch in any way refers to the DOP to figure out whether it should switch, like saying, okay, when the density values or the voxel count is below a certain amount, then switch, it would have to, on every frame, it would have to cook the DOP in order to assess the voxel count. So then it doesn't actually help us. It does switch to nothing, and therefore it overrides the frames with nothing. So our caches will be optimized and will clean up all those empty frames. Well, those frames that weren't empty and now they should be empty, yes, we get that from it. But what we don't get is that sort of lightness. It still is cooking the sim for all of the frames, even when there's no values, right? Because it has to assess everything, it has to cook everything that you are referring to with any expressions, okay? So we have to not do that. And that's why it's really important to do this, this trick here where we are keeping this empty geometry and not all of the volume, because now we have just this empty geometry. And although that geometry now refers to the sim, so it would force it to cook inside the solver when we switch. We switch to the previous frame and we are analyzing the first input. So we're only analyzing the previous frame input. So nothing about this switch actually refers to the second input. It just switches to the second input when the value is true. So as soon as it gets stuck in that infinite loop of looking at the previous frame, finding the value is true, therefore its own value becomes false, and so it looks at the first input and then it just does that infinite loop. In that whole infinite loop, it no longer needs to look at the sim because it doesn't care, right? Nothing about it refers to the sim. And therefore, as long as our switch over here refers to this switch only, then it does not need to look at the sim to figure out whether it should keep simulating. It just looks at this value, which is the output of the null that has a detail attribute for us, okay? So that way, as soon as it switches, the sim is no longer even cooked, and it just instantly caches the rest of your timeline as 1 kilobyte files and saves you a hell of a lot of time, and then also obviously disk space. Now I do also have it looking at our start frame here as well. So I've got two conditions. One that says basically when the frame is less than the start frame, then it should be true. And if this condition is true, then it should be true. And then I'm basically saying if any condition is true, then it switches to the second input. What that means is basically before the start frame, this will be just caching nothing. From the start frame forward, it will cache something until that other condition is also true, which it will be true and persistent. So it'll be false until it becomes true. Once it's true, it'll stay true forever. Okay, and as soon as that is true, the switch switches to the second input and then caches nothing, and that's very fast. Okay, so the only other little caveat or thing I want to add is that the start frame of this solver needs to be set to the start frame value from this solver, because what you want to do, or basically the start frame of the sim, either way, it doesn't matter. It just needs that value, and then you want to give it a little bit of padding. You want to give it a few frames, like 10 frames or something, to say, okay, well, because my simulation is probably going to be at least 10 frames, right, for my density values to fade off. And even if it's not, 10 frames is not a lot to cache, so it's not that much wasted time. But you want to let it start only 10 frames into the sim so that you don't have it be true that there's no voxels when the sim begins. Okay, that would not be good. You want to let the sim get going, then start and say, right, from this point forwards, as soon as there's no voxels left, then you count as true, and as soon as you're true, the switch happens and it switches to nothing, and then it caches nothing. Okay, and there we have it. So although this kind of looks a little bit complicated, once it's set up, you can really easily just plug this in and set your conditions, and it works. Now I'm going to show you how this works. Here in my cache, you'll see there's nothing, and these frames were super quick to calculate because there is absolutely nothing, right? Then it starts simulating, there's our smoke, and then you'll see as soon as it fades off, it switches and there's absolutely nothing, right? Now that was based on this modulate by speed, and in fact I also even had this plugged in, right? So my collision geometry, which is my flippy that's moving around, was included, and that's the result we get. Okay, now what if I change this, right? Without having to figure out my start frame, my end frame, nothing. I just make a change, right? And in this case, what I'm going to do is I'm going to have a different modulate by speed. So here I was going between 2 and 5, I'm fading up. Well, here I'm going between 6 and 8. So it's a lot higher of a threshold, which means the speed has to be much more before it is even emitting anything. So it's only really at the apex of that swing where it reaches enough velocity to release any sim. And you can see there our source is much tighter. It only releases for a small amount, then it stops, and then right at the end it starts up again. So there's a gap, and then it emits a second time. Okay, if I just simply plug that in, so I'm going to go to my first frame, plug that in, and then on my cache I just say save to disk. Because I have initialized simulation ops on, it's going to re-trigger all of my plugged in solvers, including these that are calculating the sim frame, and then it's going to calculate, right? Now I'm going to do this now, but obviously I'll speed up so you can kind of see. So you saw in the beginning there, it shoots through a whole bunch of nothing frames because of that switch. Now you'll see it's recalculating, well, like it's actually caching these frames out, and then I'll just speed up a little bit, and then you'll see at the end there where we get to the last frame, it's going to just shoot through. And there we have it. You see how that instantly shot through the last few frames because none of those frames were necessary. They were caching just a null, right? Just an empty input. But the absolute trick, like I really want to emphasize this point, if you just do this with a normal switch or anything, any expression that is pointing to the sim in order to figure out whether or not there's voxels, it's pointless exercise because it will have to cook. This condition means that it kind of remembers once it's true and then no longer looks at the input, which no longer cooks the sim, which is why it switches and calculates everything instantly. So a very cool technique, not only for this, but actually the understanding the way that Houdini calculates what it needs to cook and using these switch ifs can be used on a whole lot of other things. So a lot of really cool techniques here for you to simulate, optimize your simulations. Also, I'll show you the results of our sim. There we go. So you'll see it only emits for a much shorter range of frames, and then also calculates there, and then everything else is just empty, right? And it's overwritten those frames that had voxel values, and now it has nothing. Completely procedural. If my animation changed, I could change my time shift here, I could change the threshold, anything, change the whole sim. The dissipation value in the sim is going to affect the final frame. Everything is going to affect it, but now it basically has an automatic start frame and an automatic end frame. Okay, right, so I hope that was really useful. I hope you guys use it all the time. I'm actually going to be building these into some DoubleJump tools. And then they're going to be more universally useful. There will be presets for this auto start frame and auto end frame, but there's also other things you can do with it. So you can set the condition to be something else. It could be not just voxel count, you could do point count, primitive count, you could do primitive value, or the presence of a certain attribute, or there's a whole lot of conditions you can set, and then basically you can either make it sticky or persistent, right? So once it switches and stays, almost like a trip switch. Or you could have a mode where it is live, so it goes true, false whenever it's true or false, because maybe you want that. So maybe you want to emit whenever some other condition is true, then you could use that mode. And then there's the time shift mode that's basically like, right, so we want to cook the whole thing, calculate and come out with one answer, and then tell me when it switched. So the frame where it switches is also important. So there's these three kind of modes for it, and you can put any condition in there that you want. That's the tool I'm busy building, so it'll hopefully come out soon. So look out for that, and then you can use that. But even before that comes out, this works. You can build this setup for yourself and use it on all of your simulations, and then as soon as the tool comes out, then it's just a much easier way, and you don't have to keep copying this into your scenes, but rather just use the DoubleJump tool. All right. So thanks very much, everyone, and I'll see you.